Alrighty, and now we're back on track with inorganic compounds. Inorganic compounds are those that do not contain carbon, more specifically those that do not contain carbon and hydrogen. Examples of these would be acids, bases, and salts. Acids will dissociate and give hydrogen ions to water. In other words, they give protons to aqueous solutions or solutions that have lots of water in them, whereas bases will actually accept those hydrogen ions. They have more hydroxide or OH ions when dissolved in water. A salt will dissociate into positive and negative ions when they are dissolved in water. So when you mix an acid and a base, it actually will create a salt and water solution. And this is an example of that. We have an acid like hydrochloric acid right here, HCl, dissolving in water. And what do we see given off? That H molecule, or that proton from our HCl molecule. In this situation, we have potassium hydroxide, which is a base. When that dissociates in water, it's giving off a hydroxide ion. You mix the two together, and now we get KCl, our potassium chloride. And potassium chloride would be the salt, and then water would be the other product of that reaction. pH is measured on a scale of 0 to 14. Anything less than 7 is acidic. Anything greater than 7 is considered basic or alkaline. 7 would be the neutral point on the pH scale. 7 is actually the pH of pure water. Most of the water that comes out of our tap is slightly acidic or basic depending on the nutrients that our water may have in it. It picks up some solvents as it's going through the pipes and such. Saliva is slightly acidic, blood is slightly basic, so various solutions in our body are going to be on either side of that pH scale. Something like stomach acid is very, very acidic, whereas some of the areas of like our small intestines, for example, are more on the basic side. pH scale is actually a measurement of the number of hydrogens in the solution. In other words, the number of hydrogen ions in the solution, protons in that solution. pH stands for actually the potential of hydrogen. So in other words, how much hydrogen is in that solution. Something that has a pH of 2 is 10 times more acidic than something that has the pH of 5. But something that has a pH of 2 is 1,000 times more acidic than something that has a pH of 5. The pH scale is a logarithmic scale, so every number difference on the pH scale is actually a 10-fold change in concentration. Here you can see that pH scale, and it's measuring, of course, the number of hydrogen ions and the number of hydroxide or OH ions across the scale, and you can see here something that has a pH of 1 has 10 to the negative 1 hydrogen ions, or 10 to the negative 13 hydroxide ions. So lots of hydrogens, not that many hydroxide ions in that solution. Things that are in this pH range are things like gastric juice or stomach acid, in the pH range of 1.2 to 3.0. Lemon juice is also very acidic. Check out vinegar at 3.0, or even a carbonated soft drink, the soda that you just drank for lunch today, has a pH of 3.0 and 3.5. Think about what that's doing to your teeth, right? Coffee is actually slightly acidic as well. Things in our body, saliva is here at 6.4 to 6.9. Like I said, slightly acidic. Blood is more on the basic side, just on the other side of 7. Semen, cerebrospinal fluid, bile are all also on the basic side. Check out, just for informational purposes here, semen has a pH of 7.2 to 7.6 compared to vaginal fluid, which has a pH of 3.5 to 4.5. So you can imagine when those two substances come into contact with one another, they equal or neutralize each other. Buffers are important substances in the body. Blood actually acts as a buffer in our body, helping to absorb any acids or bases that we bring in, which is why when we're drinking coffee or soda, which have a slightly acidic pH, our blood pH doesn't actually change, because our blood has particular buffers in it to help maintain that 7.35 to 7.45 pH. A buffer is literally a chemical compound that will help neutralize a solution. It will help keep a solution within a particular pH range. This is an example of one of our buffer systems in our body, the bicarbonate ion. Here, HCO3 helps absorb extra hydrogen ions to become carbonic acid, which is a weak acid. So these two molecules kind of hem and haw back and forth within our blood depending on if there's more hydrogen ions available or more hydroxide ions available to help make sure that our blood maintains a particular pH of 735 to 745. This video animation here goes through acids and bases for you. We're going to stop here with inorganic compounds, and then we'll start organic compounds with our next presentation.